Okay, guys, let's start. Well, let me see. Let's start. Hey, Perna, welcome. Since Perna appeared on stage, what do you think to start with the machine emulator? Is Vitor or will be Diego? Vitor. Welcome to
Hello.
stage, Vitor. Hello.
Hello, Claudio.
Can you share the machine
Yeah,
emulator team achievements?
sure.
Great. Let's go.
Hello, everyone. My name is Victor. I'm here to present the November Dev Recap. It's the progress for the October development, the report for the October development progress. The agenda for today is quick. It's small. It's a new set of features for small features, fixes, and improvements. Also, we have some progress on the microarchitecture and the hypervisor as well. There are some changes that went into the kernel tools and toolchain. After the WebAssembly prototype, we decided to do some changes on the build process so we can support the WebAssembly as well. Also, there are work in progress on the output unification and the stateless execution mode, also known as Lambda. So for the new small set of features, I'll call here Eduardo. Eduardo, can you please?
Yeah, hello everyone. So the machine got some new features. The first one is the new initialization system for adding commands to execute as a privileged user or a dApp user when you start up the machine. Then there is also a new dash IT options for a better terminal experience. It allows to have bigger terminals and some terminal features when you are prototyping the Cartesi machine. We also simplified the emulator by removing the ROM, so there is no need to install ROM anymore. It was replaced by DTB. It's a new memory range inside the machine that replaced ROM. We also replaced the way the kernel loads drives. There is now the pmem drive that you use instead of the mtd drive. It's faster and simple. And Diego made some memory range introspection in the machine.
All right.
Victor.
Yes.
So this screenshot shows the new init system. You can append commands to be executed as root and commands to be executed as the dApp user. The dash init will execute the commands as user when initializing the machine. And the entry point will execute as the dApp user. You can also set the user to execute and the working directory, as you see in this example. So show the next slide, Victor. And this is the better terminal. So you can see you can show emojis inside the machine, and it shows a bigger terminal. It has more lines and columns, so you can execute larger commands in interactive mode.
All right. Thank you, Eduardo. This is awesome. Next, there were some fixes and improvements. I will ask Diego.
Hi. So, as Eduardo said, we now have this memory range introspection that allows us to compute the machine hash from outside of the machine. And we use this in our tests, and using this new feature, we could simplify all the tests that we do a lot. So everybody's happy about this. We also fixed some build issues on macOS for people using Homebrew. And also older Ubuntu platforms in the case of proto buffers. As we support more and more of different platforms, we're slowly making the emulator easier and easier to build. We now have enabled rollups by default, and this is something that everybody who's using the Cartesi machine at the moment, almost everybody will want. And so we made it the default rather than the forcing users to add the line, the option. Because we can now compute the hash in a much simpler way from outside of the machine, we don't need this feature of dumping PMAs as part of the machine class itself. You can still do this from the command line of the Cartesi machine, but now it's implemented in Lua itself. It's not something that we have to propagate to all different programming language binds that we have. And we also bumped the version of the Boost library. So those are the simple changes and fixes.
All right. Thank you, Diego. Pernambuco, you want to join us? I think you're
Maybe he
muted.
has some issue.
Hello, can you hear me?
Yeah.
Okay, hi everyone. So this is a very brief update on the progress made on the microarchitecture implementation of the Cartesi machine. The API has been simplified to have more intuitive and meaningful names. And now we have the embedded image of the microarchitecture inside the emulator executable. We have the ability to verify reset operations by generating logs that can be sent to the blockchain for verification solidity. And we have improved test coverage and some critical bug fixes, so it's getting better. So, yeah, thank you. That's all. Victor?
All right. Thank you, Pernambuco. And for the hypervisor, I'll call Alex.
Yes, thank you. Hi guys. So on the hypervisor front, we've been focusing on the testing stuff. So we adjusted the existing infrastructure, the testing infrastructure to test the hypervisor. We discovered some minor bugs that were not affecting the normal behavior, but still that were bugs. They were fixed. So now the active phase of development is completed. We are still working on a review, and now we are preparing a demo that we can package and showcase and use to showcase the hypervisor. That's it. Thank you.
All right. Thank you, Alex. For the kernel tools and toolchain, and also the output unification, Marcelo, please.
Hello, everyone. Can you hear me?
Yes.
Right. So we've added the SHA-SUM to the files generated on the tools and the image kernel repositories, just to check that integrity and security. So also on the hypervisor, the guys on the team are updating the kernel to 6.5, has better support for hypervisor. There's also improvements on the kernel panic handling, we want the emulator to catch the exit code of the app and also when the kernel panics, so we know what happens inside the emulator. So our GenX2 fork, we're renaming it to avoid confusion, so it's easier to give support and to know if the users installed it correctly. So we're renaming it to GenX2FS, and also adding a ARM64 build to CI. And there was also a couple of improvements on block calculation and some cleanup, because now we require libarchive to build. And on output unification, so this is still work in progress, and since we're dealing with the other teams directly, there's a lot of discussions still going on, but some of the ideas I think are more established already. And so we're removing a few of the buffers from the rollups. So input metadata is going to be integrated with input. So we're going to have a single buffer for input and input metadata. So the beginning of the buffer is going to have the metadata, and the rest of the buffer is going to have the data. All of this encoded, like the VM call data. And the notice hashes and voucher hashes are going to be integrated into the output buffer, so they won't be needed anymore. And this allows us to simplify a lot the Linux driver for the rollup, and we're developing this library to help with encoding and decoding. So a lot of this library is going to be optional if you have a library for, I don't know, if you're developing the app in Rust or Go or even JavaScript, they have Web3 libraries and you can use those instead. But we think it's important to have something available for testing and a low level API for development. So we're implementing something here. And with that, back to you, Victor.
All right, thank you, Marcelo.
Sure.
So to support the WebAssembly build, we moved some libraries to the third-party dependencies and replaced the lib B64 with our own implementation to have fewer dependencies and to make it easier to build. Also, in the Lambda, we are changing the machine emulator to support the new feature. This is still a work in progress. And the idea is to have, currently to have one of the drives to be saved so it can be reused on the next input. But this will have a presentation on its own, so I will not go deep here. And yeah, so this is the update for the machine reference unit. Thank you. Claudio, back to you.
Thank you, Vitor, Marcelo, Pernambuco, Alex e Bartel. Next team, you want to jump on stage, Danilo? Oh, it was a quick jump. I'm not listening to you. Can you speak just for a test? I don't know if me or is you. Milton Stapp, are you listening? We can hear you. Yeah, Danilo. Milton is not listening to you also. Thanks, Marcos, for your feedback. Carlo also. Yeah, Danilo maybe will out and coming.
Can you hear me now?
Yeah, clearly.
Just get out of the car, get in again, start again.
Yeah. The stage is yours.
So I'll share the presentation.
Okay.
Some people are helping me. Guilherme, you wanna start with the updates for the Rollups Contracts unit?
Yeah, sure. So for the next minor version, 1.2, we have automated the release process with change sets. We've bumped yarn from 1 to 4, and there's some work in progress. So we're currently working on the quorum contract and tests and related factory contracts as well. And for the next major version, version 2, we have changed the behavior of the ERC20 portal to reject failed transfers. So now the dApp backend will no longer be notified of failed transfers. And by failed transfers, I mean calls to transfer from that return false. So just a disclaimer, most implementations of ERC20 either return true or reject or revert. So this change will not affect them. But we're doing this so to avoid the dApp backend developer from not checking the success flag. So it's more a security update. And for work in progress, we are working on the output unification front as well. So this will simplify on-chain code as well as machine emulator code. So we're storing vouchers and notices in a single tree. And we're also making an effort in making inputs blockchain agnostic. So they're self-contained blobs that contain not only the payload, but also blockchain metadata, like input sender, block, timestamp, and so on. Next, we're also making it easier to decode inputs added by portals and relays. So currently we're using the packed encoding mode, which helps us save us gas, but we noticed that has a major usability drawback. So we're using the strict encoding mode instead. And we're also working to propagate errors raised by vouchers. This should help developers debug why their vouchers are not working and so on. And on the research and design front, we have several interesting discussions, such as, and I'll just point them out because they're very rich on their own. Should we handle the return data of vouchers? And by this, we mean not only error data, but also return values. Should portal on assets? They used to own assets, but now there's some discussion whether we should revert this change. Next, should the input box Merkleize inputs? This comes from a demand from the permissionless arbitration. And lastly, should we use custom errors? There has been some discussion about usability, but also some progress. So this is also under discussion. So please join the discussions in the Rollups Contract repository. The link is in the slides. And that's it. Thank you.
Okay, so next up is Dave. Actually, one of the members of the Dave team is Gabriel. Gabriel is currently in Turkey for the next ETH event. He's actually doing a presentation there about Dave. So one of his tasks last week was to prepare for this presentation. Another topic here is we are onboarding a new member, Sophia. I don't know if Sophia is in the call. And he's also working on some modules of the Dave system, like the input reader, machine, and Merkle tree. He'll probably give more details in the next call. Next up, the node unit. Linneo, are you
Yeah, I'm here. So we are still working on the reader mode with the new claimer service. We plan to release this soon. So with this new service, anyone will be able to run reader mode locally without making claims, because this part will be a separate service. But if you still need to be the validator, you can run this service as well. We are also working on a single container to run the node service, and this will simplify greatly the infrastructure necessary to run the node. We are also working on end-to-end tests and the infrastructure necessary to run them to further improve the node. And finally, we are starting to work on a simplified version of the node written in Go, which will also reduce the infrastructure necessary to run it. And eventually, it won't even require Docker to run the node. That's it.
Thank you, Linil. Next up, Explorer unit. Bruno, I can give Bruno's update. We added safe global support, the safe support to the Cartesi scan, so you can use the Cartesi scan website inside safe for those who need multi-sig operations. And we also added a new feature for ERC20 deposits through the Cartesi scan. And in terms of work in progress, we are also developing a deposit native tokens like Ethereum and a screen to send raw inputs to applications. And finally, we are implementing the connection feature to applications so we can see not only the inputs, but also the outputs of the applications like notices, reports, and vouchers through the Cartesi scan. Updates for the Sunodo unit. Before we talk about Sunodo, one small update is that we bumped the version of the Rollups node used by the Honeypot dApp, which is on mainnet. We are now using the version 1.1. And we are also improving a lot of infrastructure that we use to run the Honeypot, and another example in a cloud environment, reducing cost and analyzing the applications that are running there. In the Sunodo unit, we released 0.9. 0.9 introduces Explorer integration, so you can have your own version of the Cartesi scan locally to your application that you are developing. We also bumped the version of Rollups node to use the latest version 1.1, and there are a few other bug fixes and small improvements that we did thanks to everyone who used Sunodo in the last event that we had, the Cartesi experiment week. We found a few bugs and we fixed them. And in terms of work in progress, I can say the main feature we are working on is the deployment system for applications to testnet or mainnet. This will be using IPFS, for example, to publish machines, and there is a system for validator rewards based on a ERC20 token. So we have some information already available in the documentation. If anyone wants to understand more details, drop us a message in the Discord channel. That's all from me, Claudio. Back to you.
Thank you, Danilo, and everyone that helped on that. Before we jump to the other units, we have also prototype unit to talk. We have Carsten to talk about the machine emulator. I would just reinforce that you can put your questions in the message box. We are being very effective on this call. So we already had machine emulator team, which is the team that develops our machine emulator, the VM, when it runs our backend. We already had the team doing the on-chain part, the node part. We had some nice news about having a reader node coming soon. Also, a single container for those that already developed with Cartesi. And try to run a node will be happy with that news. So people interested in know what are the consequences, why we're doing things like that. Those are also valid questions, okay? Don't be shy. There is no dumb question. So, are you okay, Carlo? Oh, he will rejoin. What test speak? Not listen to you yet,
Okay.
Carl.
Can you see the preview, Ron?
Yeah. Not seeing the screen sharing yet. Just square rolling. Still loading.
Okay, so Marcus, you're seeing, but Milton, you're not. Okay.
Max
so
not seeing.
Part of the audience is seeing, another one not.
I'm not seeing yet, but maybe I'm.
Okay. Let's skip to Carsten then.
Okay. Can you switch, Carsten?
I need whoever is sharing his screen to not do it right now because otherwise.
Carsten, I'm listening to you, but very low. Could you please?
Yeah. Can you hear me now?
Yeah.
Yeah. So what I was saying was that I can't share my screen because it's still being shared by somebody. Like it says I can't click share my screen.
Maybe Carlo.
So if Carlo can jump on and then try to disconnect again.
Yeah, already disconnected mine, so.
Okay, now I just let's see. Do you see my screen? Okay, so I'll just switch. Okay, so we have a few things going on. Of course, a lot of things is kind of like under preparation for DevConnect at the moment. But one of the things we've been playing around with this month is playing with Cartesi machines with IPFS as the dehashing device. And because we don't have a dehashing device yet, we call it proto dehashing. So we're kind of like using yield and kind of using the APIs there to facilitate the IPFS data store plugin running inside a Cartesi machine that will basically dehash an IPFS block by talking to a modified rollup HTTP service. So basically, from point of view of a, let's say, developer experience, IPFS cat or the IPFS ID, IPFS API will basically work as normal and it will dehash and get blocks from outside because we're kind of playing around with a concept where kind of like the rollup state is in IPFS, where we're using the IPFS beautiful file system and basically outside the Cartesi machine as the thing managing and we will basically block get from the IPFS API and kind of feed it back to the machine and kind of playing around with that this is maybe a way that kind of other Cartesi machines could potentially address the state of another Cartesi machine this way. Just I'm a big content addressed fan, and dehashing is basically content addressing. So let's see what we can do with this. One of the things that we're working hard on is that we are doing a 5-minute demo on Iglea Station Summit, where basically we're showing that we have consensus done by Tendermint, which is, let's say, it's a consensus making framework, I don't know how to describe correctly, where Tendermint will get the validators from Iglea, coming in, kind of claiming a certain weight that they are a particular public key, and get that information from Eigenlayer as in restaking, and also manual monitor kind of like validators come and leave. And how this connects together with Cartesi is basically we can quite easily make high proof of stake kind of networks where we compute something in a deterministic manner together with a Cartesi, we're using a Cartesi machine, sign it using a majority of the network, which is restaked F validator stuff, and relay it back to Ethereum. And we'll basically be demoing this for those 5 minutes on that summit. Of course, we did the hard hackathon participation. So we did Cartesi on Bitcoin during that week, and we kind of like compiled the Cartesi RISC 5-step from C to Boolean circuit. And later on, we made a small Boolean circuit to Bitcoin script converter. And one of the kind of like advantages that's happening on this side of the space is that kind of like they're moving away from kind of like having to bisect gates to bisect on instructional circuit bisections, which means that it might actually get practical, as in you don't need to wait 300 weeks for your result to actually be for proofs. So it might actually get to that we will have viable computing on Bitcoin despite every effort to stop that. We have also continued with, let's say, implementing the Lua stuff in Rust, and kind of like now interacting with the Dave team to kind of like, now that they got to the point where it's no longer a Lua prototype, but just actual Rust code they want to have, and kind of like integrating those things together. We did, I think it was this month, but time flies, you know. We rickrolled the Expresso testnet, as you might have seen in our marketing. We had the R&D call together with Benedict Bunz and so on. We made kind of like our small Lambda thing, which is like a small, using a sequencer, collecting notices, vouchers, and so on. So, and kind of emulating the same kind of rollups experience behavior. And then something that we did today, and I got told that actually works today, but I haven't seen the demo myself, is that we tried using the same kind of like modularity that we created for Expresso backend, and we tried testing this with Celestia instead. And as you know, Celestia went mainnet recently. So we made some quick and dirty Rust bindings for Celestia, and I made a typo there that's terribly embarrassing. And basically, we wanted to try and see if we kind of make the same modular integration for the mainnet. For the demo, we kind of use for rickroll, but the problem is that it's 2 megabyte max block size at the moment there, so it can't be a full rickroll. And yeah, that's pretty much it from us for this time around.
Thanks, Carson. Nice. A lot of cool things. Let's go, Carlo. You are muted.
Just a second.
Can
you see the screen now?
Yeah.
Okay, guys. So, quick summary of what we worked on this past month. So multiple projects that we maintain, like the CoinToss example, we're making use of a Chainlink Oracle for random numbers, a token price application that also makes usage of a Chainlink Oracle only for fetching the token prices. An echo that's updated with additional functionality, the Rollups framework, and a generic front end we have that is quite used on hackathons and others to kickstart Cartesi applications. They were all updated to version 1.0 of Cartesi Rollups, so it was a lot of effort. Another thing that we had to do is create this deployment scheme for external contracts in case of this integration of Chainlink oracles for the CoinToss and the token prices dApps. All of this stuff are available under GitHub repos, so you can check it out later. We still have the ongoing high-level frameworks, which are meant for making it easier and more enjoyable to develop new dApps on Cartesi. So the Python one is one that advanced a lot back this month, along with the specification for the dApps protocol.
which hopefully at some point will start generating automatically code for the client and for the server side. And also the Go framework advanced a bit as well. Just like the other units, we were also part of the Cartesi experimentation week, and the members from our unit took place in two different groups. One that developed a decentralized rideshare application, Uber similar, and another one that's meant to do creators economy for courses and other online contexts, which is called Tribes. So just giving a quick view of the rideshare one. We had this mobile application in which you enter your destination and you also connect to your wallet. You request for a ride. Interested parties will offer you to take you there. You choose which one you want. And after the ride is done, you can just conclude it and have it paid. So just a quick overview of some of the interesting things in here. The way we developed this is privacy first. So there's no way of someone checking that a particular address is coming from some place to another place every day or all this kind of stuff. So we use some nifty zero knowledge stuff, both for the payment and also for the reputation updates. So you still have the guarantee that the driver you're taking is a respectful person and that they have completed a number of trips and that it was well evaluated, but keeping the privacy. Okay. And the other project, which is Tribes, has this forum-like interface in kind of like Kickstarter or Indiegogo, and you can create new proposals for courses, for online contents, and it has a reverse bidding logic in which the guys that want less return offering more money are the ones selected. So it prioritizes the content creator. And yeah, decentralized as well. And both of these projects, they made use of the Python high-level framework. So they also boosted improvements on those. So yeah, those are the main things I wanted to talk about. If you guys have some doubt, some questions, anything like that, we're happy to answer you.
Thanks, Carlo. It was nice to close this session of presentations with a very cool example. People, please add your questions. I would like to start to take benefit that's fresh in our minds, the FAST project. Carlo, you mentioned the Fast Furious as Shahin mentioned in the chat. You mentioned in your presentation about the Python high-level framework. Could you share more info about that for our audience? Is it public? Where people can find it? What does it allows developers to do? How it make it easier to develop Cartesi dApps? Could you please bring more info about that?
Yeah, sure. So the basic structure of Cartesi dApp is you have this iterator, which interacts with our HTTP interface. And you have to talk to this finish endpoint, both to say what you have, if you accepted or not the last input, and also to request the next thing you should process, either inspect, which is doesn't change the state of application. It's kind of like a read-only call, and also to advanced state, which is what actually moves the application state forward. Right? But there are a lot of things that are kind of like cumbersome, because when you're coming from a web to development, and the reasoning of having this wrapper that's HTTP interface is to ease things for this kind of people. You're generally used of using a framework that has routes, for instance. So you just have a route, you have URL parameters and others. And the framework in general offers you something easy to access those, right? So that's one of the things that's being added on this high-level framework. So for the ones that are used to Django or Flask or another Python web framework, the experience should be much easier. You can just put a decorator in there. The decorator has a specification of the route, of the URL parameters, that kind of stuff. And the framework magically makes all these parameters and stuff appear to you and does the routing on the background. So that's one of the functionalities that's being added in there. There are other things like implementing high-level interfaces for vouchers that are being worked on. And it makes much more easier and much more intuitive for people to develop a Cartesi application when you come from a well-known Web 2 framework development background.
Well, thank you, Carlos. And also adding that Sunodo, which is the framework, the development framework and infrastructure for deploying the apps, also has support for creating a template for creating Cartesi dApps using Python. So who didn't have the chance to take a look, it's a good take to test it. We have a question here from our community. Let me share. Okay, from Lincoln. Can you guys explain more about the partnership with Eigenlayer? I didn't really catch what's the deal in the previous intervention. Thanks. Carsten, could you take that?
I already
Not
answered
list-
in the text, basically, but I'll just
Oh,
repeat
sorry.
it here for the people who are just listening. So basically, we're just doing a demo, essentially, in Restaking Summit, and we got invited to do so by the team. Eigenlayer has some open APIs and playgrounds, and we kind of look at what you can do combining contested deterministic compute and high restaked value proof of stake networks using Eigenlayer and Tendermint in this particular case. And we believe there's many use cases that could kind of benefit from this kind of high stake off-chain computation that isn't strictly speaking a rollup form. And just want to kind of remark on the partnership that it's a very funny term in a decentralized ecosystem. But if anybody's asking me if they might see me doing a selfie with the founder of Eigenlayer in Istanbul DevConnect, this might happen.
Hello, everybody. Do you hear me?
Sorry,
Yeah,
I just disconnected. Go ahead, Milton.
No, I was going to entertain people while you were away.
Okay. More questions, guys? Let me check here.
We can take the opportunity here. We will have tomorrow at 14 hours UTC, I believe. A more in-depth representation for DFS from Carlo. We'll let you guys know in the general channel. So that
Okay.
just to let you guys know.
Okay. We don't have any more community questions for now. Any core developer?
I have some questions.
Oh, that's your time.
Yeah, so like to invite Carsten back to the stage if he's still around. I would really love to understand better both many things that you said. So there are, I'll leave two of them for you to answer. One is how this product dehashing works and what is missing for it. And then the next one is how do you see the next steps in the work you're doing while playing with integrating with Espresso?
Yeah, so let's start with the last big question, because that's what I was hearing last. With Expresso, what we're doing at the moment is kind of like trying to get things into a state where we easily can take in applications that are originally written for kind of like the existing Rollups code. And that's what we kind of been doing for the last week or two, where we are then patching that in with kind of like reproducible Ubuntu builds, kind of Docker containers. And I think that right now there's going to be some bigger changes happening in Expresso on kind of like on the way that they're doing commitments and so on, and data availability. So we need to kind of take a look at what happens with those. But what we're aiming for in general is that we have kind of like a little bit like a modular runtime that we can kind of like easily synchronize to with Expresso sequencer essentially. So it's a little bit like our kind of experimental playground that we're playing with here, but it might be eventually useful in one way or the other. Could you remind me again what the first question was?
Sure, that's great to hear. So the other question was how this proto dehashing with IPFS works and what's missing.
Okay. Yeah, so the proto dehashing is basically a way of signaling back, like the application signaling, the dApp signaling back to the host it's sitting in, that it would like to request a particular hash, which then gets basically written into the typical rollup transaction buffers, right? So kind of like a little bit making it possible to do proto dehashing today until we actually have a real dehashing device that would include arbitration and so on. So we kind of start playing around with the concept already. And I thought, because I don't feel like that it's that necessary that we are that close to kind of like how Ethereum does things, that what can we do if we start treating it more like an interface to IPFS, and what kind of interesting things can we do there? And I mean, we can already kind of like fetch blocks in this manner, but what we're doing on top of that is kind of like making a nice user interface so you can use the IPFS APIs as normally inside a Cartesi machine, because there's an actual IPFS daemon running, and get blocks from outside. And this will naturally happen in a deterministic manner because it's content addressed, and as you should only be asking about hashes that you know you can actually fetch. And then what we're then playing around with is what if we could, instead of having, let's say, the typical way of thinking about state, which is like the Cartesi machine is more like in a lambda form, where we could think about the state as being closer to something hosted in IPFS instead. So that's kind of like what we're playing around with right now.
That's pretty mind-blowing. So do you see that there's a chance that we could actually run arbitration with this kind of IPFS form?
I mean, there's no reason why we couldn't, right? Because IPFS CID is essentially a hash type, like it's called a multi-hash and a hash. And then, of course, we are restricted to hashes that are inside working with EVM at the moment if we're communicating with that. But essentially, it's something that if the dehashing works, the dehashing device works as described, then there's no reason why we can't go in and essentially pick off IPFS, right? If we assume that, let's say that for example, let's say the input is our current state in IPFS, then there's no reason why we shouldn't be able to kind of dehash that down, actually access the different, let's say, parts of the state, right? And it also gives a benefit that then when you actually need to access the state from outside, like for example in an app, you can basically look it up using IPFS as well.
Yeah, I'll need to think about it a lot. I'm not sure if anybody who's more into the arbitration, the hashing side wants to comment. If not, we can move to some other topic. Does anybody want to jump in here?
The problem is that right now it's like maximum 256 kilobyte blocks, which is not out of the question to do arbitration around, but it's a little expensive.
Yeah. All right. Thanks a lot, Carson.
It seems like Linko liked a lot dFast and is asking what's next for dFast, if it will become a real dApp to be launched and things like that. Carlo, I think you're...
Yeah, go ahead.
So yeah, as I said on the chat, it's too soon to say. I think it does have potential, but at the moment we want to wind up developing the base functionalities that we imagine and also polish it a bit. Once we have this complete proof of concept, let's put it this way, then we can discuss about making a pilot or something like this.
Just reminding that dFast was the app that was developed during the experiment week that we had on Cartesi, not only involving Cartesi core developers, there was also community devs. And it was fascinating to see that with our MVP, our first version of the SDK, it was we were able to develop a lot of cool dApps. dFast is just one. So people that don't know about Experiment Week, please check our blog and our Twitter to see more information about that you will have links for the other projects that were also very cool projects. So I think that's it. We have our questions. Anyone else?
I have another question. I'm very inquisitive today. If possible, Danilo would like to go a little bit more in deep about deployment system, if it's possible to already. You said that there was a link to a place where more details could be seen, so if you could share more when you're around. Yeah, thank you.
Yeah, so there's a bit of information. It's still outdated, but it's available at docs.sonodo.io. I can share the link later. So basically, there will be a system where validators will be able to register themselves as validators and choose your C20 token as payment method for running nodes for third parties. So the choice of which ERC20 token will be by the validator. And the system will, in the first version, will support Kubernetes environments. So if you run infrastructure on the cloud, you can choose any infrastructure provider that provides Kubernetes support. You can choose AWS, Google, Microsoft, Linode, any major cloud provider supports Kubernetes. We'll be able to use Sonodo to run a validator service, right? So there will be like a decentralized system for validation. So as a user, you can choose which validator you want to use. As of now, we only have authority system while Dave is being developed. So during deployment, the developer will choose which authority he's going to use, which is also the validator. And from that point on, he can deposit tokens, the tokens chosen by the validator. So he can deposit those tokens, and those tokens will be like the fuel of the application from that point on. So as long as the application has enough funds, the node will be executed by the validator. So that's basically how it works. and we are also using IPFS as the distribution mechanism for the Cartesi machines. So the Sonodo developer builds the application, tests the application locally, and when it's time to deploy, the Cartesi machines get packaged into IPFS, and the validator on the other end will fetch the machine from IPFS and start the node for the application, as long as the application has funds to execute. So that's basically how it works.
That's very, very cool. Hope to see that soon. So, Claudio, do we have any other topic? I'm done with my questions. Thank you.
No more questions, Milton. Just sharing here that Cynthia put the link for the blog post where everyone can know more about the Cartesi Experiment Week. There is a recap there, explaining the initiative, the projects that were done, that were built. So please check it out. That's it, guys. 11 o'clock. Nice to see everyone here, and see you soon in the next Dev Recap.